Hello grade 9 students. Welcome to another virtual class. I am Miss Madhu Vadke. We are studying chapter 4 linear equations in two variables. In previous two classes we have learned how to represent a linear equation in two variables on graph paper. We know that a linear equation of the type ax plus by plus c equal to 0 represents a straight line on the Cartesian plane, and that every point of this line is a solution of this equation. We have also represented equations of the type y equal to kx, where the constant term is 0. This is also a linear equation which will represent a straight line on the graph, but it will pass through the origin. In today's video lesson, we will use this knowledge to answer the questions of exercise 4.3. We have already answered 3 questions of this exercise in previous 2 classes. So let's continue from the 5th one, and we will solve the 4th one later in this video lesson. From the choices given below, choose the equation whose graphs are given. So this is the first graph for which 4 equations are given, and we have to choose the one that corresponds to this line or represents this line. Observe that this line passes through the origin. Therefore, this equation has c term 0. This implies that the 4th one does not represent this line on the graph, as it has a constant term which is 2. Now let's take the first equation, y equal to x. In last video class I have shown you how to check which equation represents this line. We have to take each of the points that are marked on the line and substitute in the equation and check whether the left hand side is equal to right hand side. So if I take the first point, that is minus 1, 1, the x coordinate is minus 1, y coordinate is 1. So y equal to x will be wrong because minus 1 is not equal to 1. So even this equation does not fit. Let's look at the third one, y equal to 2x. Let's take the same point. The x coordinate is minus 1, so if I substitute here minus 1, 2 into minus 1 is minus 2, so value of y is minus 2. But here the corresponding value of y is 1. Hence, even this equation will not be correct. Therefore, equation 2 is the correct equation. Now the method that I used here to find the right equation is by elimination. What I did was I eliminated the wrong answers. So now I am left with the correct answer. We can verify whether this equation represents this line by the usual method of substituting these points that are given on the line in this equation to check whether left hand side is equal to right hand side. So the 3 points are minus 1, 1, 0, 0, and 1, minus 1. So the x coordinate is minus 1, y coordinate is 1. So the left hand side of the equation is x plus y and right hand side is 0. So left hand side of the equation will be minus 1 plus 1, and that is equal to 0. X coordinate is 0, y coordinate is 0. Therefore, substituting in x plus y, we get 0 plus 0 equal to 0. For the third point, x coordinate is 1, y coordinate is minus 1. So the left hand side of the equation will be x plus y, which is 1 minus 1, which is equal to 0. So all these 3 points satisfy the equation. Here is the second graph with 4 equations. All these equations are of the type ax plus by plus c equal to 0, where there is a constant term. Now in previous video class I had explained the constant term represents the distance of the point from the origin where the graph cuts the y-axis. When this equation is written as y in terms of x. Observe that y is on the left hand side and rest all of the terms are on the right hand side for the first three equations. Notice that from the origin, the point where the graph cuts the y-axis is at a distance of 2 units, plus 2 units. So, y equal to x plus 2 could be the equation, but y equal to x minus 2 will not be the equation because the value of c is minus 2, whereas the graph cuts the y-axis on the positive side. The third equation, y equal to minus x plus 2, can also represent this line as the constant term is plus 2. And definitely the fourth one is not the correct answer because the constant term is not plus 2. So we can eliminate the second and the fourth equations. Now we have to check only for these two equations. Now if you are finding this method of elimination difficult, you can simply substitute these points in each of these equations and then check whether the left hand side is equal to right hand side or not. So let's take point A, which is minus 1, 3. That means x is equal to minus 1 and y is equal to 3. So the left hand side of the equation is y, which is equal to 3. The right hand side of the equation is x plus 2, which is equal to minus 1 plus 2, which is equal to 1. So left hand side is not equal to right hand side. This means that this equation is also not correct. We will now test the third equation, which is y equal to minus x plus 2. So let's take the first point A, minus 1, 3. This implies x is equal to minus 1, y is equal to 3. So left hand side of the equation is y, which is equal to 3. Right hand side of the equation is minus x plus 2. On substituting x, we will get minus 1 plus 2, which is equal to 1 plus 2, and that is equal to 3. So this implies the left hand side is equal to right hand side. So this point satisfies the third equation. Let's check point B. Point B is 0, 2. So this implies that x is equal to 0 and y is equal to 2. So left hand side of the equation is y, which is equal to 2, and the right hand side of the equation is minus x plus 2. Substitute x here, so we get minus 0 plus 2, which is same as 2. So we get left hand side equal to right hand side. So this implies that point B also satisfies this equation. Similarly, we have to check for the third point C, where x coordinate is 2 and y coordinate is 0. So the left hand side of the equation is y, which is equal to 0. Right hand side of the equation is minus x plus 2, which is equal to minus 2 plus 2. On adding, that is 0. So the left hand side is equal to right hand side, and therefore point C also satisfies this equation. So this line represents y equal to minus x plus 2. Question number 4 of the same exercise. The taxi fare in a city is as follows. For the first kilometer, the fare is rupees 8, and for the subsequent distance, it is rupees 5 per kilometer. Taking the distance covered as x kilometer and total fare as rupees y, write a linear equation for this information and draw its graph. According to the question, we have to take the total distance covered by the taxi as x kilometers and the total fare for that distance as y rupees. It is given that for the first kilometer, there is a fixed charge which is rupees 8, and for subsequent distance, the charge is rupees 5 per kilometer. So if a person covers a total distance of x kilometers, then the fare for the first kilometer is rupees 8 and the fare for the remaining distance, that is x minus 1 kilometer, is charged at rupees 5 per kilometer. So now there are two parts in this fare. When we add these two parts, we will get the total fare that is equal to y. Now what are these parts? The first part is the fixed charge for the first kilometer, which is rupees 8, and the second part of the charge is for the remaining kilometers, which is charged at the rate of rupees 5 per kilometer. So we will multiply 5 with the number of kilometers that are remaining. So this will be the equation that will represent this situation. But we need to write this equation in the standard form. So we will simplify the right hand side. On simplifying the right hand side, we get 8 plus 5x minus 5. Add the constant terms. So 8 minus 5 is plus 3. So y is equal to 5x plus 3. This is the equation in reduced form. Now we need to find the solutions of this equation so that we can plot or represent this equation on the graph. Now remember that x represents the total distance covered, which cannot be negative. Hence, we will not choose negative values for x. Likewise, y represents the total cost or the fare of taxi, which again cannot be negative. Hence, we will avoid negative values for y. So let's draw the table to write down the solutions of this equation. We must find at least 3 points to plot on the graph. Let's take values of x as 3, 4 and 5. So when you substitute x as 3, 3 times 5 is 15, 15 plus 3 is 18. So y will be 18. When you substitute x as 4, 5 into 4 is 20 and 20 plus 3 is 23. And we can guess the third value by noticing the increase in the value of y with respect to x. Value of x increases by 1 and value of y is increasing by 5. You can substitute x as 5 and then check. 5 into 5 is 25 plus 3 is 28. So we have 3 points to represent on the graph. Let's now represent these points on the graph. Since the x coordinates and the y coordinates are positive, we need to represent only the first quadrant on the graph. So draw the y-axis, label it as y, y dash, and the x-axis and label it as x dash, x. On the x-axis, we will mark numbers 1, 2, 3, 4, 5. And on the y-axis, we have to represent numbers till 28. So we will have to choose a suitable scale on y-axis in order to represent all these numbers. So let's take 1 centimeter on the y-axis as 10 rupees. So this will be 10, this will be 20, and this will be 30. Now label your x-axis. X coordinate represents the distance traveled by the taxi in kilometers, and the y coordinate represents the taxi fare in rupees. So label your axis accordingly. Before you start plotting, you have to write down the scale that you have chosen for x-axis and y-axis. Now you must write down the scale on the top right corner, but I am writing on the left side because this part will be covered with watermark. So on x-axis, 1 centimeter represents 1 kilometer, and on the y-axis, 1 centimeter represents 10 rupees. So let's plot the points now. The first point is 3, 18. So from the origin, you will move 3 units along the x-axis, and from there you will move along the y-axis and reach till 18. So 18 is this point. That will be 2 small divisions less than 20. Second point is 4, 23. So from origin, move 4 units along the x-axis. From there, move along the y-axis and reach 23. So 23 will be 3 small divisions above 20, which is this point. The third point is 5, 28. From origin, move 5 units along the x-axis, and from there move along the y-axis, and we reach here, which is 28, 2 small divisions less than 30. Now we will join these points to get a straight line. Don't forget to mark the arrows at the ends of this line, and also label this line with the corresponding equation. So notice that when we represent a word problem on the graph, we have to label the x-axis and the y-axis according to the quantities that are given in the question. Also, we need to write down the scale that we have chosen. So now the solution for question number 4 is complete. From this word problem, we extracted a linear equation in 2 variables. We found the solution set containing 3 points, and we plotted these points on the graph to get a line, which is representing this equation. Now this graph paper is enlarged so that the points can be seen when they are being plotted on the graph. However, you can use a different scale so that this graph looks bigger when it is plotted on actual graph paper. With this, we come to the end of this video lesson. Your assignment is to answer these 2 questions. See you in the next class. Until then, goodbye.